Hey guys, Justine here from Compass Tutoring. Today we're going to be exploring the topic of domain and range. So a fairly basic skill, but something I feel that, needs a bit of brushing up upon sometimes. So we're just going to go through the basic ideas of domain and range, look through some examples, and determine the different ways that we can find the domain and range of different functions. So we can have the graphs, and from the graphs we can determine the domain and range, or we can have the actual function in algebraic form, and from that we can determine the domain and the range. Okay, so in basic terms, the domain is defined as all the possible x coordinates of a function. And the range is the set of all possible y coordinates. Okay, so when you have a function, you graph your function on a Cartesian plane. A Cartesian plane is comprised of a y-axis and an x-axis. And so these are just basically two number lines that have been put together to form this Cartesian plane. So the domain is all the x values where the function exists, and the range is all the y values. That's why we have two sets, an x and a y, because we have two different number lines. So let's consider our first example over here. So we have this line that passes through y equals 2. So first we determine the domain. So the domain of this function, we're looking for all the possible x values that exist on this function. So we look at all the x values and we see all the x values are being represented in this function. Therefore, we can conclude that the domain of this function is all real values of x. So we say all real x. And then the range of this function, we look at all the y values that are being represented on this curve or on this function. And we can see only y equals 2. Y equals 3 is up here, and it's not obviously being represented. Y equals 1 is down here, it's not being represented. So it's just the coordinate, or it's just the value of y equals 2 that's being represented in this curve. So the range of this function is y equals 2. Let's consider this next example. So we have a parabolic function. So first we look at the domain. So we're going to look for all x values that are represented on this curve. So once again, let's consider some negative x values. So they're being represented all on this part of the graph. X equals 0 is right here. All the positive x values are here, and they continue up to here. So once again, the domain of this function is all real values of x. Now to determine the range of this function, so we're looking for all y values that are being represented on this curve. So let's consider all these positive y values here. So they are all being represented here, right? You keep coming down to the negative y values, and so you have y equals -1 is over here, but anything below -1 is not being represented on the curve there. So therefore we conclude that the range of this function is y is greater than or equal to -1, because y is equal to -1, and also any value is greater than -1, not less than -1. So this is how we can write the range. Moving on to the next example. So let's consider the domain first. So let's consider all the x values that are being represented on this function. So let's consider the negative x values, which are here. So as you can see, they're being all represented. X equals 0 is also being represented, and all these positive x values are being represented, and the curve continues. So once again, the domain of this function is all real x. And then the range of this function, we're going to look for all the y values that are being represented on this curve. So you see y equals 1 is an asymptote. So it's something that the graph approaches but never reaches, okay? So we look for values greater than 1. Obviously the curve doesn't exist there, so no values greater than 1 exist. We look for values less than 1, and we see them being represented all along here. So y cannot be 1, but it can be less than 1. So we say y is less than 1. That's the range of this function over here. Then we'll move on to this next example. So let's consider the domain. So once again, the domain is all the x values that are being represented on this curve. So let's consider the negative x values. So all these negative x values here are being represented here, all the way down to here. But once we reach this value of x equals 0, this is actually an asymptote of this curve. So just like this one here, the asymptote is something the graph approaches but never reaches. So for the value of x equals 0, this curve or this function never reaches that. So x equals 0 is not represented in this curve, in this function. So, so we know x equals 0 is not represented. So we continue moving in the positive direction and we see all these positive values are being represented. So the only x coordinate that is not represented is x equals 0. So the domain is all real x except x cannot equal 0. So all values of x exist on this function except the value of x equals 0. And then we consider the range of this function. So we consider all the positive y values, they're all being represented here. When we come to y equals 0, this is another asymptote that the curve approaches. So once again, y cannot be 0, and we continue moving in the negative direction and we see these negative y values being represented. So just like the domain, the range of this function is all real y except y cannot equal 0 for the exact same reason that x cannot equal 0. Okay, so now let's consider our function in a different form. So now let's consider the algebraic form of a function. There are 3 things to look at when determining the domain and the range of your function in algebraic form. And the first thing to look, or the first thing to consider is whether or not it is absurd. So the reason this is important is because we know that any value under a surd cannot be negative. We can't have something like the square root of -1. Something like that just doesn't exist. So we know that when we're considering a function with a surd, anything under the surd has to be 0 or positive. It has to be greater than or equal to 0. So we can have something like the square root of 0, that does exist. And we can have the square root of anything positive, like 1, 2, 3, 4, whatever, even fractions. But we cannot have the square root of a negative number, which is why this idea is going to help us determine the domain of this function. So, first thing we consider is everything under the square root. So everything under the square root, x plus 3, is greater than or equal to 0 because we know that we cannot have a negative number underneath the surd. So once we determine this in equation, we can follow through to find the value of x. So we move the -3 over, or we subtract 3 from both sides, we get x is greater than or equal to -3. So that is the domain of this function, because anything less than -3 is going to yield a negative answer. And like we said before, we cannot have a negative square root. So the domain of this function is x is greater than or equal to -3. To determine the range of this function, you're going to need to graph the curves. Okay, so this is our curve here. So now to determine the range of this function, we're going to look at all the y values that are being represented on this curve. So we start at y equals 0, it's being represented there, and so forth, all these values here, and the curve continues, so do the y values. So the range of this function is y is greater than or equal to 0, because there are no negative y values that are represented on this curve, but there is the value of y equals 0 here, and anything above that is also represented. So the range is y is greater than or equal to 0. Okay, so the second thing to consider when determining the domain in the algebraic form is to check whether or not your function exists as a fraction. So this function exists as a fraction, so it's 1 over 4 minus x. So the restriction on a fraction is that the denominator cannot equal 0. So this is the second rule. So that's the restriction, and that's what's going to help us determine the domain of this function. So the domain of this function, the function is 1 over 4 minus x. So we know that the denominator cannot equal 0. So what we are going to do is equate it to 0 and then find for what values of x is it 0. So the first thing we're going to do is equate the denominator to 0. So 4 minus x equals 0. And then we simply make x the subject of the equation. So x equals 4. So we know that for a value of 4, the denominator is 0. Therefore, the domain of this function, x cannot equal 4, because we know that the denominator cannot equal 0. So any other value of x can exist except the value of 4. Then to determine the range of this function, we're going to have to graph the curve. Okay, so this is our curve here. So to determine the range of this function, we look at all the y values that are being represented on the function, and we say that all positive and negative y values are being represented except for the value of y equals 0. So it's all real y except y cannot equal 0. Then we'll move on to the last example. So this is a combination of the last two that we did. So it's a combination of the surd and the fraction. So with the surd, we said that everything under the square root, so let's just say we have the square root of x, so x has to be greater than or equal to 0. And with the fraction, we said that the denominator, let's just say this is our function, the denominator cannot equal 0. So from these two exceptions, we can determine the domain of this function. So the surd states that it has to be positive and equal to 0, and the fraction states that it cannot be equal to 0. So from both of these restrictions, we derive that x has to be positive. So the overlap between these two is x is positive. And we know that x is what's under the surd and what's on the denominator. So we take what's under the square root and we make it positive. And then we just simply solve for x. So we get x is less than 1. So therefore, the domain of this function is x is less than 1. And if we wanted to determine the range of this function, then we would once again graph the curve and determine the range. This is a bit of an odd one, so I'm not going to go through that process, but I just want you to understand how when you have both of these limits on your function, making, I guess, what's under the surd and what's in the fraction positive satisfies both of these restrictions. And there we have it, domain and range. I hope that helps.